Now for the last even, odd, neither, worksheet 6. What I need you to realize is that the absolute value graph, which you should recognize, is similar to the x squared graph. It's an even function because another way we think of even functions is just by thinking of the exponent x squared. Whenever positive and negative is applied and you get a positive, then it's even. And 0, of course, stays 0. So an absolute value function's an even. So when I see f of x equals the absolute value of the quantity x to the 5th power, it's even because the absolute value of x is even. Now, the exponent doesn't matter here. When you see an absolute x, think of x squared because they act similarly. Their values are, y values are different, but they have the same sign. So, for example, once you have an even exponent, when you're raising it to a power, it stays even. So the absolute value, once even, an odd exponent can't do anything to it. Just think of it. We're going to talk about it in a few minutes. Even times odd is still going to be even when we do an even multiplication of exponents only. Now notice down here, by inspection, this is even, so that's an even function. But here's the important thing you need to know. The absolute value of negative x means the same thing as negative 1 times x. The absolute value of negative 1 is 1, and it leaves me with x again. So whenever you see absolute value negative x, you can call it absolute value x, or when you see absolute value x, you can call it absolute value negative x. Because think of this, if this is negative 2, this is positive 2. If x is 2 here, this is negative 2, this is positive 2, they get the same answer. So with that in mind, let's now do this by using the proof. I substitute my negative x in, Negative x to the 4th is x to the 4th. What's the absolute value of negative x? We found out it was x. These now look exactly alike, so I'm even. I could have done it by inspection. I say, oh, numerator, you're even, denominator, you're even, and even divided by even plus over plus is even. Let's revisit problem 1 and do a proof. I put in negative x for the inside the absolute value, but that's the same thing as x. Now these two match and it's even. Let's revisit and prove number 2. Substitute negative x in, but what's the absolute value of negative x? It's the same as positive x. And so we see these two match, and so I conclude by saying it's f of x and it's even. Now, just like when we had rational functions and we had even over even was even, and odd over odd was even, and odd over even is odd, when we multiply functions, even times even is even, odd times odd is even, and odd times even is even. So by inspection, I see it's an odd times an even product. Odd times even is odd. I see it's an odd term. So odd times odd is going to give me even. I'm going to do the proofs of these. So when I insert my negative x, I get a negative x cubed. I put in my negative x, I get x squared. When I look at the original expression, everything's positive. Over here, it's just negative times. And so I see my function is odd. In this one, here's your original expression. I'm going to put in a negative x, negative x, negative x. I come over here and do this. I end up with this. I have to do a little chicanery. Factor out the negative 1. Now negative times negative is positive. And now when I look at this, the only negative sign is in the same place as this one. So h of negative x is equal to h of x, and I am even.